Okay, this is TEAS Mock Science version 6. The version numbers do not necessarily coincide with the order you're doing them in. That depends on how the test is flowing at the time that I have you doing these as to what goes with what. So this is part of, currently, this could change, part of extra set 3, extra mock set 3. I'm going to go very quickly here. I'm going to mostly just give answers. There's a few things I'm going to explain. Just like I said with Mock Science 5, when you get into the 5 and 6 and 7 area, there are some questions that are harder than what they're going to look like on the real test. This one, not as much as with 5. What I would say about this one, depending what you miss, you might curve yourself up like a couple of percentage points if you miss the things that I point out as being difficult. The main thing that makes this one a little harder than what you're probably going to have in front of you on the test is there's some questions that I have 3 blanks or 2 blanks, and I use that more than the test does. So on this particular test, you had a lot of scenarios where you filled in 2 or 3 different blanks in the same question. And that makes it challenging from an accuracy standpoint because it's so easy. If you have to put that many things in, it's easy to overlook something and have the wrong thing in one of the spots. You will have a question or 2 that's like that. So I don't make that style up out of thin air. It does come from the TEAS, just not as many, because the aim of a mock is mostly to see where you're scoring and give you practice, but to also try to give you a little bit of review. So some of these questions, I built them a little bigger so that I could review with you. This mock also has some new content. And anytime I say new content, that is relative to when you're seeing the recording. And so this is currently early March of 2019. If you are watching this prior to, I'm going to say May or June of 2019, some of this may be new and you may not have heard it, or you may have heard it in one of the classes, but not quite to the extent or not quite in the style. So if you happen to be part of the group that's taking this the minute that it becomes available, there are, I would say, 3 or 4 things probably that you're going to learn from this mock. And you don't have to worry about 15 other formats of the question or anything like that. It's just going to be very similar to what I show you here. So you may experience a few things for the first time. If you do, don't count that necessarily against your score. Give yourself a bit of a curve. But then you've seen some things that are just brand new, just started circulating or just started recirculating, as is the case with a lot of things that I had eventually cut out of the curriculum because it was extra. Now it's back. So there will be a few things that you're actually going to learn from this mock, as long as you feel like what I say makes sense. Don't take the point from yourself or give yourself half of a curve or whatever, as far as scoring goes. So number 1 is a very simple question from Life Science 1. A crystalline structure is like saying it's solid. So I put that in there as a reminder to you guys. That is talked about in class. So if we're talking about a solid, it's fixed for both. Number 2, precipitation is the result of what process or processes. Precipitation is a cycle. We do talk about this in Life Science 1. First, there's evaporation, then there's condensation. So if water never evaporated, then it couldn't rain because there wouldn't be water in the sky to rain. So if they're talking about precipitation, evaporation naturally happens from lakes and oceans and the like, and then condenses when it hits a certain altitude. It gets colder. Condenses, makes what we know as a cloud, which is a good example of condensation, and then might rain after the cloud. Number 3, the balanced form of this chemical equation has what number in the given blanks? So remember that when you do this, what you want to do is start with a little chart where you list out your components to make sure that you're updating in real time. So on the left-hand side, I've got 2 and 2. On the right-hand side, I've got 4 of these and 2 of these. So what I end up needing to do is put a 2 there so that instead of this saying 2, it now says 4, and then these match and these match. This is a little tricky because there's an extra blank that you didn't end up using. The answer to this one is going to be B, because if you don't alter something, as we didn't alter in this case, if you did not alter something, it would be a 1. So if there has to be a number sitting next to O2, but we didn't mess with it, that number is going to be 1. Number 4, this chemical is an example of. So identifying certain types of chemical reactions is something that used to be around a lot, and it's kind of coming back. There's only a few of them that you're really going to need to know. There's really only 2 that you need to know, and those are single and double replacement reactions. A single replacement, what you're going to see with that is one thing moves from one spot to another when you go across the arrow. Double replacement, 2 things move. And so the way that they do these that makes them really obvious is, let's say, is using A, B, and C. And I'm going to show you how to apply this to the question in a minute. But using A, B, C, and D can really clarify what's going on in your equation. So let's say that right now I have, let me space these a little bit better. I have A over here by itself, and then I have B and C, then I have an arrow, and we can do this with the question that you're actually seeing in front of you. Let me zoom in and make it a little bit bigger. So we would call this A, this B, and this C. So each chemical has its own letter. Now, if that's A, B, and C, when we go over to the other side, Cl is what we're calling A, so that's here. Na is what we're calling B, so that's there. And Br was C, so that's there. This is a single replacement reaction because one letter moved from one place to another. So the A moved. Everything else is essentially in the same spot. So that would make this a single replacement. A double replacement, let's say that we have A and B together in a compound, and we have C and D together in a compound. And then over here, you're going to see that 2 letters move as opposed to 1. So if this winds up saying AC and BD, that's a double replacement because 2 things moved out of their spot and into another spot. The other dead giveaway, and this is a cheat sort of thing that you can really use pretty effectively. A single replacement reaction, and again, for your context, if you get asked what kind of equation something is and it's along these lines, there's only a couple of possible ways you could ever answer that because the TEAS has a very limited scope. There's actually 3. One of them is something we've talked about already, and that would be an oxidation or reduction. Remember that oxidation reduction is when something goes from positive to negative when it goes across, or from negative to positive. So if something said Na here, and then we go across the arrow, and now it's Na minus, what happened here is it gained an electron. That's why it went negative. Gaining an electron is called reduction. One more example for oxidation reduction in case this is not ringing a bell. This is from Life Science 2. You can totally go back to oxidation and reduction. That is heavily lectured in that class. Let's do an example of oxidation. So let's say that we have Cl2 minus on this side, and when we cross the equal sign, we end up with Cl plus. So what happened here? I lost 3 electrons. Why is it 3 and not 2? Because if I had lost just those 2, it would just say Cl. It would be neutral without a charge either direction. That would make it perfectly neutral. Since I have a plus, I went from -2 to -1 to 0 to 1, and that was 1, 2, 3 electrons. So what would I say about this particular equation? I would say that Cl was oxidized. That is review. That is something you have learned. So identifying oxidation or reduction is going to have to do with the plus and minus signs. The ones that aren't talked about heavily but will be in the new curriculum soon, so if you're taking this a few months from now, you did learn this, is single and double replacement. If you use the ABC or the ABCD, you don't have to know a darn thing about chemistry. If you look at the equation we have here, there was nowhere that we could put the letter D, right? We didn't have a place to put a D because there's only 3 compounds. That's what you're going to see with a single replacement reaction. There's going to be 3 of them in the first place. So when you go to label your separate components, you're going to have an A, a B, and a C. And then one of them moves. So you would either go from like AB plus C to B plus AC, something like that. One letter moves. 3 to begin with. 3 letters. 1 moves. Double replacement, there will be 4 letters. So you'll have 2 different compounds. You'll have like NaCl and H2O, for example. So A, B, C, D. 2 of them will move. So you'll have like AB plus CD become AC plus DB or something like that. So again, there's always a make it or break it when a brand new concept comes up. What I encourage you to do, and this is absolutely into the future as well as now with the TEAS, there's 2 ways that people react to something that they've never seen. You're sitting here on a mock, so that heightens your reaction because you're testing, you're about to take this huge test, you're finding something out for the first time, and you're like, oh my goodness, now there's something I've got to know. And then Emily barely explained it. We just barely went through it. There's 2 possible reactions you can have to that. You can panic and think, oh my gosh, I need to know so much more about this. I got to go find this. I need to do a lecture over this. Or you can say, and this is true in this context, everything you needed to know about that, we just did. So my lecture, when that does exist for this, will be pretty identical to what I just did. So all you need to know about these single and double replacement is what we just said. All you need to do to be effective with them is, and I'm going to zoom this in again to give us some space, all you need to do to be effective with these is you see this, you see that this is what the question is that they're asking, and you label, just like I had you do. So first compound we're going to call A. The second compound we're going to call B. The third one we're going to call C. Now we're at the arrow, right? So there's not a fourth. You automatically know single replacement is how you're going to answer this. You don't even have to do the replacement to figure that out. It's right there in front of you. If you were to be doing this and you were to have 4 letters, so let's say I'll use black to do this so that it looks convincing. Let's say that that said NaCl instead of just Cl. Again, you see that this is what you're being asked. You go through and find each chemical and label it with a letter. Just the fact that there's an A, B, C, and D tells you that this is where you're going to be at, even if you don't witness the switch. You will see that it switches. So there's kind of a couple possibilities. This could have been A, B, C, D, and then it could have turned out when the replacement happens, it could be A, C, B, D. So one letter from each pair swapped places. Or it could be B, D, and A, C, or B, C, and A, D. But the bottom line is 2 letters, any 2, swapped places. If it's oxidation reduction, because that's the other possibility, and that's the one that you have been working on, you're going to see pluses and minuses. It is an absolute giveaway just looking at this right now that that's not going to get answered with oxidation reduction. There's no positive or negative signs anywhere. So you know it's not oxidation reduction right off the bat. They may have had that here, and you could just take those answers right out of the running because it has to have like a 2+ and a 1- and that sort of thing for that to happen. So what I'm basically asking you to do is allow yourself the absolute grace of just completely trusting me initially and then yourself. You can so easily answer these questions without really developing an understanding of chemistry because there's certain things that are going to be there for each answer. So if you go to look at your equation, you take a quick glance, you don't see any little pluses or minuses, it's not oxidation reduction. If you do see pluses and minuses, it is. And then you have to determine, is it oxidized or reduced, which requires you to have memorized from your life science that reduction is when you gain electrons and oxidation is when you lose them. So that's a process. If it is oxidation reduction, there is a few steps you have to take, but we learned those already. If it's single replacement, there's 3 compounds on each side. You label them A, B, and C, and you know what the answer is. If it's double replacement, there's 4 total. So you go to label them and you find that you have A, B, C, and D. You know it's double replacement. They are not going to ask you combustion. They're not going to ask you decomposition. They can ask you reduction or oxidation. But when you very first glance at the equation, you'll automatically, as soon as you glance at it, you'll know that it's either one of these 2 and therefore not one of those, or vice versa, it's one of these 2 and it's not one of those. If it's got little plus and minus signs, it's either oxidation or reduction. You can proceed from there with your process to figure out which. If it doesn't have little pluses and minuses, it's a replacement reaction. You determine whether you have 3 players in the game or 4. Hopefully that makes sense. It's very, very, very simple. So I strongly encourage you, if you feel at all overwhelmed or slighted or concerned or any of the things that you could be feeling, you shouldn't be. I certainly wouldn't discourage you from redoing that explanation a time or 2 or 5 or 6 times so that you can get up to speed because it's a new concept. But trust me when I give you the simple, just do this, look for that, do this, look for that. Trust those and trust yourself with those and just add that to your mental log right now and it's in there and you're good. So there's nothing to worry about or panic about. It's just something you need to know that you're looking for when you go to do one of those. Free point. If you miss this, I can assure you there will be no more than 1 question about that. You will not have 5 questions that ask you for equation types. You'll have 1 or none. So if you don't catch that, if it just doesn't click or you just get a really weird one, don't worry about it. It's 1 point. Number 5 is A. Number 5 is also something that is re-emerging. Long story made very short, an aquaporin is a membrane protein. I'm sure you guys remember, not with me, but in other situations that you studied the membrane proteins. And there's like the ones that kind of come together like a puzzle piece like this and they open up. There's the ones that have a channel through them. There's the ones that carry. So when you're looking at a cell, and we'll say a human cell for right now, cell membranes have the ability to transfer water in and out of them. So the semi-permeable membrane in and of itself does transfer water in and out. Water can come in and out of the cell, but that is a slow process. So just in normal conditions, a cell can allow water to come in slowly, or a cell can send water out slowly. And that's totally normal. That's normal conditions. A aquaporin is a particular type of channel that makes this much faster. Again, don't be concerned that you need to know all kinds of things about membrane proteins and diffusion and aquaporins and all that. You don't need to know anything except that. So essentially, what you need to know is the stuff about diffusion that we've already talked about with anatomy. The fact that the way oxygen and carbon dioxide exchange is using diffusion, the way oxygen goes into the tissues uses diffusion, the kidneys filter using diffusion, all of that should sound like totally duh. I know that because I learned that. We talked about all that. Now we're just going to add one little thing to that, which is an aquaporin is a channel that lets water go directly in and out of the cell so that it doesn't take nearly as long. So you could be asked something like what I have here. You could be asked any number of possible combinations with that in mind. So what you need to know is an aquaporin is a membrane channel protein. And you could just get asked that. And you need to know that the reason it's there is to let water come in and out much faster than it normally would. So the key thing you need to know is that. You do need to know about diffusion because we talk about that with all the different anatomies. You don't need to know details about diffusion. You just need to know that all these processes in the body where things are switching spots happen using diffusion. And then you need to know what an aquaporin is and that speeds up the water moving in and out. That's the new stuff. Again, if you're taking this 4 months from now and onward for the 1.5 years that this edition will be out, you did learn that. So anytime, if you're listening to me on a mock and you're like, why is she acting like this is new? I learned that in class. Don't worry. It's because at the very moment I'm making this, it had not been taught in the same manner. 6 is going to be B. The only organelle we know that specifically is there for storage is a vacuole. That's what stores water in a plant cell. That's from Life Science 1. A lysosome destroys waste, so that's totally different. A nucleus houses DNA. I could see possibly a few of you answering nucleus because you might think of it like, yeah, the DNA is stored in the nucleus. That would be an error in thought process because the purpose of this organelle is storage. The purpose of the nucleus is to house and protect DNA. That's where it lives. That's its place. That is not the same thing as storing something. So a cell storing something, that would not be the nucleus because the nucleus is built that way for a reason. Same thing with like the rough ER that has the ribosomes all over it. That's not considered storage of ribosomes. That's considered where they are. I promise this will totally speed up from this point forward because those were most of the hard ones. 7 is from Life Science 1, and it's going to be all of the above. They don't do all of the above on those, just so you know. So all the other questions you've seen in the past that I've shown you of these, you answer with one thing. That's what it's going to be like. The reason I did all of the above was to help remind you of what they are. And don't forget, there's one more that still didn't make the list. Know all 4 of them. Also know that what your question will say is which of the following do all cells have or every cell has, and you'll pick one of them because there will only be one there. Number 8 is life science 1 as well. It's all random on the test. The TEAS is totally random. You'll notice that my mocks are not random. You'll notice that I have all the life science right in the front. Then I have all the science reasoning, and then I have all the anatomy. And you'll notice I largely have the anatomy grouped by system. That's because of how I organize and write these. It is totally random on the test. You will have 32 anatomy questions, 8 life science questions, and 7 science reasoning questions. On my mocks, your life science and science reasoning are out of the way in the first 2 pages. Main function of the ER network, it's talking about the whole network. So we need to factor in all the components, synthesize, package, and transport proteins. Number 9 is from Science Reasoning 1. Testability is a very important attribute for a hypothesis. A hypothesis should be testable, and it should be possible to repeat a test again and again for somebody else to do the test and repeat your test, and so on. 10 is from Science Reasoning 1. The first step in an experiment, you've got to have a topic. So 10 and 11 go together. The TEAS does not do paired questions ever. I did this because on all my other mocks, I focus you guys on knowing that you're supposed to do research first. So you're kind of used to what should you do first? Research. What should I do first? Research. You've gotten used to that. That could wind up being an error on my part to cause you to think that directly to research, because remember, you can't research something unless you have something to research. So the very first step, and this is number 1 on your science reasoning list of scientific method steps, is to choose a topic. 11 is going to be research the topic. So these 2 questions were put here to help clarify that for you and remind you of that. Obviously, you have to have a topic before you can do anything at all, of course. So it's going to depend on the context of how something is asked. Usually when they ask you the first step, they're actually kind of talking about the second step. But you're going to know that because it's going to describe what you want to know. So if they say, oh, this person wants to study this, and that's in the question, obviously they've picked a topic because the topic is actually in the question for you to see. 12, most experiments can be made more accurate by what course of action? We've talked extensively about these questions. It's always going to be specific. It's going to be a specific experiment. It's going to be described for you, and they're going to ask you how you could improve it. We worked on that extensively in Science Reasoning 1. This one, I went really broad to make sure that you know that it's almost always the same answer. Every experiment you can imagine would be made better with more trials. Having more test subjects, trying it more times, repeating the process over and over is the best thing you could do in an experiment, period. All the other things that you have there are not something you would want to do. You cannot have more than one independent variable, so B would be the worst thing you could do. Having more dependent variables does not help with accuracy at all. It maybe brings a little more info out of the experiment, but info that's disconnected from the original info. You don't need a unique independent variable. You're not trying to be unique. If you're trying to be unique, you might miss the boat. You need a strong independent variable. You need just one independent variable. That's what's crucial about that. 13 is from Science Reasoning 2. Nope, hold on. I switched the order here. From Science Reasoning 1, I swapped these questions. So this says a scientist wishes to test the effect of sodium consumption on blood pressure. This is what I was just referencing. So they want to know what's the first step or what's the next step. Obviously, they've selected a topic because they told us what it is. So their next step is going to be to do research about, has anybody ever tested sodium and blood pressure? What do we know about that? That's the research step. So in this case, your first, I'm going to put quotes around it, your first step is research because you clearly have a topic. That's what I was referencing a minute ago. Number 14, which of the following is the best approximation for the height of a tree? This comes from Science Reasoning 2. 4 meters is the only thing they have sitting there that makes any sense at all. A meter is like a yardstick, which is about 3 feet. You could have a tree that's 1 meter tall. You could have a tree that's 15 meters tall. But you couldn't have a tree that's 100 millimeters tall because that's teeny, 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 teeny. Like smaller than your finger, teeny. 2 kilometers is like 2 miles. So you certainly wouldn't find a tree quite that big, not even the biggest trees. 3,000 meters is about a third of a mile. And if you don't want to think of it that way, 3,000 meters, just try for half a second to picture putting 3,000 yardsticks together. Clearly, that's going to be way too big for even the biggest tree. So the only one that makes sense is 4 meters. That's a possible approximation. That's a possible height. You are in no way saying most trees are that height. You're just saying that's a possible height and that the other 3 choices are not possible for height. Number 15 is from Life Science 1. Actually, it's not. It's from Science Reasoning 2. I don't know why I have Life Science 1. Science Reasoning 2. Life Science 1 is relevant. I'm going to put them both there because you need to know a tiny bit about bacterial conjugation and what that is. So that's the thing we talked about where there's a killed bacteria and it gets added to another bacteria that's alive, that's a different strain, and it mutates and becomes more powerful because of the dead one. The question they're asking is, how would you set that up equipment-wise? The only option they have there that makes any sense is a Petri dish. Keep in mind, it's a very specific question. A tool that could be used as the setting of the experiment. It's arguable that you may end up using an autoclave at some point, but it's not the setting of the experiment, and we can't prove that we would use an autoclave or wouldn't. A magnifying glass won't do a darn thing because we're talking about bacteria. You could have the best magnifying glass in the world and not be able to see bacteria. And a triple beam balance would be for weight. So the only thing we can say for sure would be an asset to this experiment is a Petri dish to put it in. You might remember that in class, I very specifically referenced that that is how you would do that, is with a Petri dish. 16 is reading a triple beam balance from Science Reasoning 2. This is a thing that has reemerged as well. So if you are a current student in March of 19, pay attention here. This is where I'm going to explain this. I believe I also explained it on Mock 5 as well. The only thing that's weird about a triple beam balance, really, there's only one thing that's weird about it. The 100 is in the middle, and then the tens box is above it, and the ones box is below it. So they're out of order. All you do to read a triple beam balance is you scan over the whole thing. You find the biggest number. Biggest number is 300. You find the next biggest number, that's 30. You find the smallest number, that's 5. Then you read it, and you'll get your final number. So if I just read from left to right here, 335. How do we write 335 in the real world? Like this. So you're adding that all up to a weight. It is grams, and we know that because it says grams here. I've never seen them be tricky like that just for the sake of it, but they could. So be careful that you don't say milligrams if there's something clearly labeled that it's grams. Another name for the integument or integumentary system or skin is the cutaneous membrane. A lot of systems have a membrane. In the case of the integumentary system, it actually is a membrane as well as having a membrane. That's from Anatomy 1, as well as 18 is from Anatomy 1. What is, so a disease that has impaired melanocytes, what would be true about that? An increased risk of sunburn, because melanocytes make melanin. Melanin protects us from UV. None of the other things that are listed here are things we can prove to be true. So there's only one answer that makes sense, and that's that the lack of melanin could lead to a lot more sunburn. 19 is from Anatomy 1. The blank membrane is found in and around joints and tendons. That is the synovial membrane. This is not currently on the test. This is kind of future proofing. The cutaneous membrane is the only one that is on the test now. They could totally go to the next level with that. These are the 4 possible membrane types. We know what cutaneous is. We now know what synovial is. You already know what mucous membranes are, and that only leaves serous membranes. So that's good knowledge to have. If you can store just a couple extra things, that's something to future-proof your knowledge for the test. 20 is from Anatomy 1, the scapula, which is another way of saying shoulder blade, the patella, and the vertebrae, and that's going to be D. 21 is from Anatomy 2. What's a hormone active when blood calcium levels are too high? So when blood calcium is too high, it's going to be calcitonin. I don't have a good way for memorizing this. I always have to look it up. I can never remember the stupid letters. Calcitonin is when blood calcium is too high. PTH and calcitrol are both when it's too low. Find a good way, and let me know if you do, because I don't have a good way, to put in your mind, permanently in your mind, to cement the fact that PTH and calcitrol do the exact same thing as one another. And calcitonin is unique, and it does the opposite of those two. So in this case, they asked about too high. There's only one hormone active when blood calcium is too high, and that is calcitonin. 22 is from Anatomy 3, and that answer is going to be C. That one you should know. 23 is from Anatomy 1. Decreasing bone mass would be like osteoporosis, which we worked extensively on. The only thing they have listed here that you could be fairly certain you would see a decrease in is the building cells, the blasts. 24 is Anatomy 2. Afferent with an A neurons carry sensory signals. Efferent with an E carry motor. Remember, those are prefixes that you can use for all kinds of things. 25 is from Anatomy 2, and that's going to be A. The part of the neuron that does the actual carrying is the axon. The fluid-filled gap is the synapse. 26 is Anatomy 2. That's going to be C. So we know that there's the increased mitochondria. We talked extensively about that. These other things that they have here are things that the muscles do. So there's 5 functions of muscle, and all of these fit into them. But the mitochondria makes energy, which puts off heat. That's the only one that is relevant to the mitochondria. So know that. Know that not only do muscle cells have extra mitochondria, that results in extra heat. That is talked about in Anatomy 2. 27 is A. That's a matter of knowing what everything is called. We went through that pretty extensively. 28, you could say, is a mix of Anatomy 1 and 2. And that's going to be C. Piloerector and erector pili are both names that are used for these muscles. It activates on the hair follicle. Your actual hair is not in contact with any muscle tissue. But your hair follicle, which if this is the skin and this is the dermis, you have your hair follicles in the dermis like that. That's where that erector pili muscle is. That's what I'm getting at with that. I have not seen anything about the hair follicle on the test as of yet, but that would be a good thing to know because it allows you to name it and it allows you to have a good mental image of it. 29 is from Anatomy 4, and that's going to be immune system. This is a common question. It's not exactly like this. Basically, it describes the fact that the skin is breached. There's a cut or whatever, a pathogen actually makes it through the skin. What they're getting at here is the skin is part of the first line of the immune system because the skin prevents most things from ever getting in just by its nature, right? If the pathogen goes through the skin or the skin is open and it's not intact, now it's the problem of the immune system. So that's what they're saying. Normally, skin protects, and that's the first defense, and it's the skin's job. If the skin is breached, however, it is now the immune system's job because it's going to be able to get in the bloodstream, and that's where the immune system fights. 30 is Anatomy 3, and that one is B. A diuretic, I'm going to do this very, very fast because this is getting a lot longer than I want it. A diuretic is a medication that helps you lose excess water. The way it does that from a practical life sense is makes your body produce tons and tons of urine to get water out of your body. I strongly recommend, as a side note, when you go into nursing school, really understanding these and understanding their role in heart failure. That is huge. For now, what I'm going to say is you just want to be logical about their answer choices. Don't get into the details. Don't worry about the details. Each answer should give you a mental image, and that mental image should either be the opposite of what you're trying to do or it should be what you're trying to do. The one that is what we would be trying to do with a diuretic is B. The reason I say that, reabsorption, very important word, reabsorption is where water is in the kidney. It's in the final stages of the kidney. It's been purified out and it's leaving. And when we see the word reabsorption, that is where the kidney makes this last second decision that that water that was about to exit to the bladder is not going to exit to the bladder. It's going to get reabsorbed back into the blood, therefore back into the body. Reabsorption of water happens when we need water, not when we're trying to get rid of water. So if you see reabsorption with a diuretic, no, can't be. That's the opposite of what we're trying to do. Reabsorption is when at the last minute, the water goes back into the body. That's basically what that means. The collecting duct is just part of the nephron. You're familiar with that because you have to memorize the steps in the nephron. That's all familiar for you. That's not important. What you're trying to get is the big picture. To increase reabsorption of water at the collecting duct, that would raise the body's water level. So that's backwards. Increasing absorption. So these two, C and D, do not say reabsorption. They just say absorption. Increasing absorption in muscles is not something you would ever say. Muscles do not absorb and reabsorb water. That's irrelevant to muscles entirely. The intestines do absorb water, right? So if you drink water, that's how it gets into the rest of your body, as your intestine absorbs it. To increase absorption of water in the intestines would again result in our body having more water, not less. You can't necessarily say anything about intestinal activity when you're talking about a diuretic anyway, because a diuretic acts on the kidneys, not the rest of the body. But you can certainly say you would not take a diuretic, and as a result of the diuretic, you take in more water in your intestine. That we can say for sure would not happen. Again, this question, the wordings that they use in these answer choices make it look a lot harder than it is. 31 is from Anatomy 3. Be careful, this is backwards. It's asked backwards. This actually happened by accident, and then I realized how good of a thing that could actually be. So they have the blank arterial carries oxygenated blood that's been purified. When we learned this in Anatomy 3, we were going in the opposite order. We were talking about entering the nephron, which is the second thing they're talking about, so that the blood can get purified. Then the second step, so this is the first step here, this is the second one there. So we're just going to kind of be backwards with our answer. That's going to be C. Why I ended up doing it backwards is to help you make sure you don't have something just memorized. You don't just want to have afferent, efferent memorized, because all they have to do for you to lose that point is swap the two. And it's factually correct, but logically it's in a weird order. So make sure that you know the afferent arterial is coming into the nephron in the first place. So that's the first one. We're just entering the kidney. The efferent, we know that EFF always follows AFF. It's always the second step. Then we've come through the neuron or the nephron, and we've been purified. So you have to know that the nephron purifies blood, and you have to pay attention to whether they're saying you're coming into that nephron or out of it. Afferent would come first, which would bring blood into the nephron. Efferent would come second, which would be bringing it out of the nephron, now purified. 32 is from Anatomy 3. This one is going to be D. Don't forget the ogen thing. Ogens in the digestive system, they don't do anything. So I did a little bit of a trick answer with B. Pepsinogen, all pepsinogen does is becomes pepsin later. That's all it does. Pepsinogen does not break down proteins. It's a precursor molecule. It's a baby. Ogens are babies. So the only answer that has two adults and adults that do protein, not any of the other types of nutrient, is D. 33 is Anatomy 3, and that's going to be B. Also from Anatomy 3, number 34 is going to be D. The purpose of the liver is bile. What bile does is emulsify fats. So that's the perfect answer because they're together. 35 is from Anatomy 2 and 3 because it's endocrine as well as reproductive. And that is going to be C. FSH comes from the pituitary and stimulates the gonads, which in the case of a male would be the testes. Stimulation of the testes would lead to more sperm production. 36, also Anatomy 3, is fallopian tube. By now, you've got that totally down. Fertilization, fallopian, fertilization, fallopian. 37 is Anatomy 4. Blood found in the right atrium is always deoxygenated blood that's coming back from the body. That's just a matter of knowing your steps and what's happening with oxygenation. 38 is from Anatomy 4. Fibrinogen and platelets are part of clotting. Fibrinogen is the protein that's part of the blood that's responsible for clotting. Platelets are like the way that fibrinogen has its responsibility for clotting, essentially. So those two words, when you see them, always refer to blood clotting. 39 is from Anatomy 4. That's going to be A. Pulmonary arteries are carrying deoxygenated blood because artery means away from the heart. And pulmonary means that it is leaving the heart, but where it's going is the lungs. Why would you go to the lungs if you had fresh oxygen, right? So deoxygenated blood would be what would leave the heart to go to the lungs. That was the harder part of this question. The second part could be the name of any artery except the pulmonary. The only artery that's deoxygenated is the pulmonary artery. So they could have said aorta, carotid, subclavian, Femoral, doesn't matter. Any artery can fill in that second one because almost every artery is oxygenated. 40 is from Anatomy 4, and it's going to be cytokines. Again, that one's drilled in your head by now, I hope. 41 is Anatomy 4. Adaptive immunity, or the third line of defense, is B and T cells. Easy to remember because they have unique names from all the others. 42 is Anatomy 4. That's going to be D. This is a question I've had a lot of people have trouble with, and I'm surprised by that because it fits very well into all the things that you know. When they say something stops functioning, what's very important is that you zone all the way into that thing and really be thinking about just that one little thing and what it's supposed to do. So don't picture the whole heart and lung process. You'll be confused. The alveoli are the site of gas exchange. The alveoli is literally where oxygen enters the blood and CO2 exits the blood. That's all that an alveoli does. So it's not going to stop the heart because it has nothing to do with that. It's not going to change things in the body. It has nothing to do with that. It's going to stop absorbing oxygen and discarding CO2. It's literally the gas exchange itself is what goes away. Nothing else that they have there makes sense. Tissues in the body will still be sending their CO2 out. Eventually, you could have an increase in CO2 overall, but that's not exactly how that would work. That's a later result. And when you're talking about in the body, at the moment that an alveoli stops functioning, remote tissues like the ones in your feet are irrelevant at that point. Blood will not stop flowing. It will just keep flowing without picking up new oxygen. And it will not stop the heart. 43 is Anatomy 4, so is 44. Emphysema is alveoli. These questions are asked differently. So this is alveoli. Chronic bronchitis is marked by a decrease in, so it's not asking you the location, a decrease in cilia. A decrease in cilia winds up with more mucus produced, and that is going to be D. 44, the cardiovascular system perfuses the respiratory. I have that in one other mock. It's just a reminder is why I put it in here. Perfusion is the exchange of liquid between organ systems, which is exactly what the heart and lungs do. That was mentioned in Anatomy 4. It's in your respiratory notes. 45 is from Anatomy 1. That's going to be D. So the blood supply, you have veins and arteries in the hypodermis because that's way down away from the surface of the body. And then you have arterioles and capillaries, the smaller vessels in the dermis. The epidermis is epithelial tissue, and epithelial tissue does not get blood supply ever. Not direct, I mean. 46 is Anatomy 1, and that's going to be A. Homeostasis is the state of being. So homeostasis is when the body is balanced and happy and how it's supposed to be. It's not the actions that put your body in balance. Those would be the mechanisms that would be called feedback, which is what the next question is about. Homeostasis is the state you want to be in. Mechanisms that correct that state or bring you back to it are feedback mechanisms. 47 is Anatomy 1. Which of the following is a negative feedback mechanism the body uses if the temperature drops to lower than optimal? 3 of those answer choices would release heat and make you cool off. 1 of them makes you warm up, and it's that simple. So that is Science Mock 6. This is part of a mock set, so don't send me this score individually. Send me this score when you have the entirety of that set done. And then send me an email that has the version number for each subject, because they won't match, how many questions you had right, and how many there were. And I will give you a final weighted score for each of your final and extra mock sets. So save this. You have one more subject most likely to do, which is English, and then send me all of them. Let me know if you have any specific questions. Go back and review any class that you missed anything out of. And I will see you guys later.